All right, people. So we're going to be moving to the next part. It says functional group part 1. Okay. So this will take us through page 14 all the way to page 17. That's where it will be. All right. First of all, what is functional group? Okay. Functional group. Now, functional group, if you see over here, it says it is a site on a molecule where a reaction is most likely to occur. So this is where a reaction will happen. So you see, for many of you, right? For many of you, you are familiar with things like you may have seen things like a double bond, all right, a double bond. And if you did high school chemistry, you would have seen things like an OH group, a hydroxyl group. Okay, you would have seen that. Those are called lone pairs. Or a carboxyl group. You would have seen something like this as well. Okay, these are called functional groups. All right, so like the earlier chapter, you came across another functional group which was an alkyne functional group. So these are functional groups. So chemical reactions will happen around these groups. Okay, so around these groups, this is where chemical reactions will happen. So these are called functional groups where chemical reactions happen. All right, so that brings us back to this. So we will come to something called haloalkanes and haloalkenes. Now halo or halo basically means halogen. All right, and so these are the halogens that we are dealing with. So halogens in the periodic table are from group 17. Okay, so they're called halogens. So fluorine, chlorine, bromine, iodine, and we will just stop there. So they become the prefixes. Okay, so remember, suffix is the family name, prefix is what comes at the front. Okay, so fluorine is abbreviated as fluoro, oro, chlorine is chloro, and bromo and iodo. Okay, so these are called haloalkanes. So you see, the rules are all given over here. Okay, rules are given over here. So what I'm going to do is I'm just going to maybe do an example with you. Okay, so first of all, let's say we have something like this. Okay, so let's say there's a chlorine here. 1 2 3 4 5 6 7 8. Okay, yeah. So and then let's say we do another example here. 1 2 3 4 4. Okay, let's say we do one more here. Okay, 5, do one more here, 5. All right, here we put the chlorine over here. Okay, now in this case, you notice that this is an alkane. There is no double bond anywhere, so this is an alkane. So this is a haloalkane. All right, haloalkane, that's what it is. So this is a group that is been added to halogen. All right, so this is a group over here. So when we start numbering, we start numbering from where there's a substitution. So we call this a substitution. So this is where a substitution has taken place. So basically what we did was we remove a hydrogen from an alkane and then we put a chlorine inside. So that's where the site of substitution is. So in this case, when we do numbering, we start from here. 1 2 3 4 5, and here we start numbering from here as well. 1 2 3 4 5. So the numbering will start from the side where it is closer to the terminal. So this side, there is one terminal over here and there's one terminal over here. So we start from where the substitution takes place. So let's say if you had another molecule given to you like this, 1 2 3 4 5, and let's say in this case the chlorine was right here in the middle. Okay, the chlorine was right here in the middle. In this case, it does not matter if you start numbering from 1 2 3 4 5, or you start numbering from 1 2 3 4 5, because either way the chlorine gets number 3. So in the first example here, the longest chain was 5 carbons. So this is called pentane. This is also called pentane. All of them are pentane. So pentane. Okay, pentane, 5 carbons, pentane. They're all pentane. All right. So they're all pentanes, and in this case, chlorine is at number 1. Chlorine is at number 1. So this is called 1 hyphen chloro. Okay, it's one word, chloropentane. And in this case, this becomes 2 chloropentane. It's one word. And in this case, this is called 3 chloropentane. It's one word. It's together. All right, so that's the name for it. So that's how we name this. So if we are dealing with an alkene, let's say we are dealing with an alkene. All right, so let's say an alkene like this. Okay, so you see here I put a double bond here, and in this case I put a chlorine over here. Okay, so I'm going to show you a slight difference now. 1 2 3 4 5. So 5 also, right? But because alkene has a double bond, it has a functional group here, we must start numbering from here. Priority is always given to a functional group. So 1 2 3 4 5. Although chlorine can also be considered as a functional group, okay, a halide group, but in terms of priority, the double bond gets a higher priority. So you should not do this. This is wrong. Okay, 1 2 3 4 5. This is wrong. Okay, do not do that. So the numbering must always start from the double bond. So in this case, this is called Pantene. Pantene, like the shampoo Pantene. Currently, chlorine is at number 5. So chloro, and then number 5 chloropentene. Okay, so that's how we do the naming process. So for anybody with double bond, we do the numbering from the side where there's a double bond. Are we okay? So let me just add on. All right, so let's say if you came across a situation where let's say you had an alkane, 1 2 3 4 5. Let's say there's a chlorine here. Let's say we put a bromine over here. Let's say we put an iodine over here. Okay, let's say we do just for the fun of it, we put another chlorine over here. Let's say you come across this type of situation. Let's say you may never come across this, but just for the sake of naming. So first thing you do is, when you look at this, you see there is no double bond. Okay, double bond does not exist. So there is no double bond. This is an alkane. So what we do, first things first, we look for the longest continuous carbon chain. And in this case, I've made it simple for you. This is the longest continuous carbon chain. Okay. Now comes the next question. Where do we do the numbering from? Okay, let's see. There's a substitution over here. There's a substitution on this side. Okay. Then there's a substitution over here. There's a substitution over here. All right. So if I start numbering from here, this will be 1 2 3 4 5 6. Okay. If I start numbering from this side, this is will be 1 2 3 4 5 6. Okay. Now let's say you do not know whether you should start the numbering from the left, the blue, or the red. Let's say you don't know. Okay, so what we're going to do is we're going to name this according to the blue numbering. So we're going to call this is again 6. This is 6, so it's going to be called hexane. Okay, so easy. This is called hexane. So then what we have here is we have 3 types of groups here. We have the bromo, we have the iodo, and then we have the chloro. So what we're going to do now is we're going to look alphabetical. So you see, alphabetically, B comes before C and C comes before I. Yes or no? Okay. So B comes. So what we're going to do is we're going to call this guy 2 hyphen bromo. Okay. Hyphen. Then comes C, right? So C is at position 1 and 6. So 1, 6, dichloro. Okay, dichloro. I'm just going to move this a little bit. Dichloro, and then hyphen again. Where's the iodine? Is at number 4. 4-iodohexane. Wow, that's the name. 2-bromo, 1,6-dichloro, 4-iodohexane. That's the name. What if I followed the red numbering? Okay, so what will be the name now? So the name would be 1, 2, 3, 4, 5 brom. Oh, sorry, I'm going to change color. So it's going to be 5-bromo. Okay, 5-bromo. Chlorine is going to be 1 and 6 again. Okay, perfect. 1,6-dichloro. How about iodine? Iodine again. Oh, iodine is number 3. 3-iodohexane. Am I right? 5-bromo, 1,6-dichloro, 3-iodo. Okay, fine. So now to answer the question, which method is correct? Is it the blue or is it the red? Now to answer this question, what we do is we add these numbers up. 2 plus 1 plus 6. So 2 plus 1 is 3, 3 plus 6 is 9, 9 plus 4 is 13. Here 5 plus 1 is 6, 6 plus 6 is 12, 12 plus 3 is 15, correct? So which number is smaller? So 13 is smaller compared to 15, right? So which means that when you did this numbering, this is correct. So this is the correct method of doing it. Oops, I deleted it. That's the correct method of doing it. Okay, but if you have a double bond, it's very easy. So if let's say in the same example here, right, if in a similar example here, if we had a double bond somewhere, let's say we put a double bond there, right? So let's complicate things a little bit. Let's put a chlorine there, put a chlorine here, let's put a bromine over here, let's put another bromine over here. Okay, so let's say we just leave this. Okay, under this circumstance, or let's say put another chlorine here. Oh my god. Okay, under these circumstances, right, whatever you do, whatever you want, the double bond always gets a priority. So it will always be 1, 2, 3, 4, 5. It will never ever be 1, 2, 3. So because if I follow the blue line, carbon gets number 2, but if I follow green, carbon gets number 3. So I will follow the blue, not the green. Okay, I'll follow the blue. So what is the name for this guy? So 5 carbons, so it's going to be pentene. So we have bromine at 2 places, so we're going to call this 4,4-dibromo hyphen, oh boy, 5, 5, 5 trichloro, and then this is going to be pent 2 in. Okay, in, oops, in. All right, so that's going to be the name. So we are going to follow the blue numbering, and this is going to be that. All right, we got it. So that's simple. So the next thing they talk about is, what's the next thing here? Okay, so we're done talking about all of these things. Benzene derivatives. Okay, derivatives of benzene. So if you remember, we talked about benzene, something we call bromobenzene, and then in this case is 1,2-dichlorobenzene. So let's say if you had another benzene molecule like this, let's say I put a circle here in the middle. If you remember, I can put a circle in the middle. So let's say there was a bromine over here. Let's say there was an iodine over here. Let's say there's a chlorine over here. Okay. So how do we do the numbering process now, right? How do we do the numbering process? So what we can do is we can start numbering from the B. Okay, so 1, 2, 3, 4, 5, 6. We can go this direction, or we can go 1, 2, 3, 4, 5, 6. We can go either direction. So if we go according to the red direction, it's going to be 1 plus 3 plus 6. It's going to be 10. If I go green, it's going to be 1 plus 3 plus 5. Can you see that? So the name for this would, if I follow the green method, right, it's going to be 1 bromo, 6 iodo, 5 chloro, and then this is supposed to be one word, so it's going to be benzene. Got it? So it's going to be 1 bromo, 6 iodo, 5 chloro, benzene. That's how we do the numbering process. Why did I start with the bromo? Because B comes before C, right? That's why I did that. But whenever you come across these type of things, you got to make sure that the total number is the smallest. Okay, total number is the smallest. Okay, so can we make this even smaller? Let's find out. Okay, let's find out if we can make this even smaller. Okay, so let's say, can we make this small? Oh, what did I just do? Sorry. Okay, sorry. Let's see if we can make this smaller. Okay, let's remove this. How do I? Can I remove these numbers here? Can I get a even smaller number? Is that even possible? I think we can. Okay, let's do this. Okay, so now I'm going to start numbering from here. All right, let's start numbering from here. 1, 2, 3, 4. Oh my god, 5, 6. I just realized while doing this, I just realized, like, we can actually do this. So this will be called 3 bromo, 1 chloro, 4 iodo, benzene. What's the number we're getting here? 3 plus 1, 4, 8. We're getting 8. Yep. I think this is better than what I did just now. So this is the correct one. So you see, we can start from whichever direction, but we got to make sure that at the end of the day, the total number that we get is going to be the smaller number. All right. So this is the correct answer, not the earlier one. This is the correct answer. So we got to start numbering from here. Okay, so this sometimes can be trial and error, but of course you will not get so complicated questions in the exam. They'll be quite straightforward. Okay, so priority, we must get the smallest number. Okay, now that brings us to the next functional group, which is an alcohol. Now alcohols are something that you guys are familiar with, right? So the functional group of alcohol, or hydroxyl, okay, is usually hydroxyl. So you end up with a suffix called -ol, and you see something that here says prefix is hydroxy. I will explain this to you later. Okay, so what is this all about? So all of these things here, I will explain it to you shortly. All right, so you see, okay, let me just add a paper here. Okay, let's do this. Now you see, an alcohol is basically, let's say we take an alkane, right? Let's say we take an alkane. Let's say we take an alkane. Oops. We take an alkane that's too close to the edge there. Okay, so this is an alkane, right? So this alkane is 1, 2, 3, 4, 5. So this is called pentane. Okay, pentane. So let's say if we remove one of the hydrogens, let's say we remove this hydrogen, and then we decide to put in, okay. So what we do is, in this case, when you have an OH group present, what you're going to do is you are going to remove the E, And then what you're going to do is you're going to put the group all in. So it's going to be called, I'm going to erase this, it's going to be called pentanol. That's it, pentanol. Or if you need to mention where the OH group is, so this is called pentan 1 all, because this is the numbering process. 1 2 3 4 5. So numbering must always start with where the functional group is. Okay, where the functional group is. So this is called pentan 1 all. But let's say if you had let's say you had two OH groups. Let's say there's another OH group over here. Okay, let's say there's another OH group. There's a double bond here. So in terms of numbering, again, we can follow the same set of numbering, 1 2 3 4 5. So now you have two OH groups. So when you have two OH groups, there is a rule that we follow. Okay, so the rule is, in this case, remember I told you the alkane is called pentane. Okay, pentane, right? 1 2 3 4 5, pentane. So what we're going to do is we're going to leave the E there. We don't disturb the E. We put a hyphen and we put a 1, comma 3 diol. So it's called diol. You see the difference? If there was only one OH, we remove the E here. But if there are two OH, we keep the E and we just add it as diol. Now let's say you had another OH somewhere here. Okay. So let's say there's another OH here. Okay, another OH here. What will be the name now? Okay, I think if I go from left to right or right to left, the numbering would be the same. So what will be the name now? So I will keep everything as it is. I will not remove the E. So the name will now become 1 3 5 triol. It's called triol. Okay, it's called triol. So you only drop the E when it is just one OH group present. If there are two OH groups present, then we keep the E. Okay, so let's say we have something like this. 1 2 3 4 5 6. Let's say we put an OH over here. Let's say there is a methyl over here. Okay, let's say something like this. Okay, so now the first thing you do is, when you look at this molecule, right, you will know that there is a functional group, and that functional group is OH. Okay, you must do everything within your power to give that OH the smallest number. So if we look for the longest chain in this structure here, the longest chain is going to look something like this. This is the longest chain. Okay, that's the longest chain. So numbering will start from here. 1 2 3 4 5 6. So the OH got number 2. So this is 6. 6 will be called hexa. It's supposed to be hexane, right? But since there's only one OH, it's supposed to be hexane. Since there is only one OH, we remove the E, and then we put a hyphen, we put a 2, and we put the word all. Hexane 2 all. And then there is a methyl at number 4. So we put a methyl 4. So 4-methyl hexane 2 all. That's the name. Okay. So that's the name for this, 4-methyl hexane 2 all. Got it? Simple. Okay, so that's how we do naming for alcohols. And there is another functional group, the last one, ethers. Okay, let me just explain to you ethers. It is not really important for you to know this. Okay, it says here you only need to be able to recognize an ether functional group, but not name the compound. You don't have to name it. You just need to be able to recognize it. So an ether functional group is it's basically when there is an oxygen linking two carbons together. That's it. When there's an oxygen linking two carbons together, that's called an ether ether group. Okay, that's called an ether group. You may have seen an ether group before when you did, if you did biology, you would have seen an ether group. This is called the, do you remember what it's called? It's called the glycosidic bond. Remember this? The glycosidic bond. So this is what linking two glucose molecules or two monosaccharides together. So that's called an ether bond. So you do not need to know how to name it. You just need to be able to recognize it. So when you see it, you know, hey, this is an ether bond. That's it. That's what it says here. All right. So that brings us to the last part here, which is amines. Okay, amines. So the prefix is amino. I will explain this to you. Sorry, the prefix is called amino and the suffix is amine. I will explain the difference here. Okay, so let me just bring up another paper here. Okay, so what does this mean? Again, the explanation is very simple. Let's say we have an alkane, right? We have an alkane. So the alkane is having all hydrogens attached to it. Okay, so this alkane is 1, 2, 3, 4, 5. So it's called pentane. Again, okay, easy, pentane. But what if we remove one of these hydrogens? Let's say we make things easy. We remove this hydrogen and we replace it with this group. Nitrogen attached to a hydrogen attached to another hydrogen. This is called an amine group. This is called an amine group. So now what we do is, just like in the case of alcohol just now, we remove the E, we put a hyphen, we put a 1, and we put a word amine. Okay, so this is number 1, number 2, number 3, number 4, number 5. So this is called pentan 1-amine. So the numbering always starts from the side where it's closer to the functional group. Pentan 1-amine. Same thing again, if you had another of the same functional group somewhere here. Okay, let's say somewhere here. Okay, let's say we put another of that functional group here. Okay, we put another functional group here. So now it was, okay, so now this is going to be called, what is it going to be called? Let's pull this up apart. Can we do that? Okay, we can. Okay, so what this is going to be called is going to be called comma. All right, it's going to be called comma 5. Okay, I got to adjust this. Sorry. Diamine. Okay, it's called diamine. But one very important thing again, I need to tell you is, in this case, maybe I should have just written the whole thing. I don't think it's better. Okay, let me just write the whole thing again. It's such a lazy way of doing things. So this is called pentane hyphen 1, 5 diamine. You notice, like just in the case of the alcohol just now, when you have two of the same functional groups, the E comes back. You see here, the E comes back when you have two of the same functional groups. So the E comes back. Got it? So that's it. That's how you do the naming for amines. So what I want to do is, I just want to quickly explain to you what does this mean by prefix amino, and then there is something here that says prefix hydroxy. Okay, I want to explain this to you. You see, let's say you have a molecule that looks like this. There's a carboxylic acid over here. This is called carboxylic acid. We have not dealt with this yet. This carboxylic acid. And let's say there is another functional group here. Let's say OH, a hydroxyl group. Okay, a hydroxyl group. When you have two groups like this, so there is one group that looks like this, carboxyl group, And then you have another group over here. This is a hydroxyl group. Okay, hydroxyl group. You have these two groups in the same molecule. So there is a priority listing. Okay, priority list. In the priority list, carboxyl is more higher priority compared to hydroxyl. Okay, so the hydroxyl is second place. So in this case, in this molecule's case, the name for this molecule is, okay, the name for this molecule, so numbering start from here, 1, 2, 3, 4. So this molecule is actually butanoic acid. That's what it is. And then what happens is, because we have another functional group there, okay, so this is called 4-hydroxy butanoic acid. So the OH from becoming an OL group now becomes a hydroxy. So this is what it means earlier when we read here. It says if it's a suffix is an ol, that means if your family name is, you become an ol, but if it's a prefix, then it's a hydroxy. Okay, hydroxy. So this is the example of it, hydroxy. And then the other one I want to show you is same thing. You may have seen this molecule before. Okay, let's say a molecule that looks something like this. You have seen this molecule before. When I draw it, you may not know what I'm doing, but if you know, then you will know. Okay, so have you seen a molecule like this before? Okay, if you don't know what this is one of those amino acids. If I'm not mistaken, this is called glycine. If I'm not mistaken, it's called glycine. It's an amino acid. All right. So in an amino acid, these are the functional groups which are present. Again, you have a carboxyl group. Okay, you have a carboxyl group, and you have an amine group present. Okay, amine group present. So there are two groups which are present. And again, in terms of priority, carboxyl has higher priority compared to amine. So when you have these two functional groups present, this molecule is a carboxylic acid. It's a carboxylic acid. So although we have not done this yet, so if this is a carboxylic acid, numbering is 1, 2. So the actual name for glycine is carboxylic acid with 2 carbons is called ethanoic acid. Ethanoic acid. So this is ethanoic acid. But there is this group here, this amine group at position number 2. So this is called 2-amino ethanoic acid. So if you remember this part here, it says if it's a prefix, then it's called an amino. So this is what it means. When it is present with a group which is higher priority, it is now relegated. Instead of being called amine, it's called amino. So the actual name for glycine, is 2-amino ethanoic acid. That is the correct name for glycine. Okay. All right. So one second. Let me just check. Okay, so that's it. I think that completes this part. The next part we'll be doing is functional groups number 2, where we will talk about aldehydes and then we talk about carboxylic acid. So the reason why I did this is just to show you, to explain to you how an OH group goes from an ol to a hydroxy, and how an amine group goes from an amine to become an amino. Okay, so that's what I wanted to show to you just now. All right, so we'll stop here. See you in the next class.